This is section 2.7. This is part 4. All of the problems we have worked so far, we've done a little bit of algebra and we ended up with 1x. Now, you know we don't always end up with 1x. We often end up with 3x, and then we have to divide both sides by 3 to find out what our answer is. So we also have a multiplication property of inequality, but here's where things differ from regular equations. Okay, if c is a positive number and we have an inequality, if a is less than b, then we are allowed to multiply both sides of an inequality by that value and everything is the same. So I can multiply both sides of an inequality by a 2 and we're all good. But if c is a negative number and I have an inequality, I am still allowed to multiply both sides by that negative number, but if I do that, my sign has to flip around. Okay? This is also division. Okay, now let me just do a quick little example to show you, to kind of convince you that this is true. We know this, right? We know that -3 is less than 5. That's true. Okay, so I have an inequality that's true. Let's try multiplying both sides by a +2 and see what we get. That gives me a -6 is less than 10, and that's still true, right? Now let's try the same thing, but let's multiply by a -2 instead. -3 times -2 is a +6. 5 times -2 is a -10. Now which of these is bigger now? The +6. So when you multiply by a negative, this is really what's happening. It's changing your signs, so what's bigger ends up changing around. Okay, so let's look at a problem where we use this division property. We are still going to be writing our answers in interval notation, and we are still going to be graphing every time. Simple problem here. 5x is less than 35. If this is an equal sign, we divide both sides by 5. We're still going to approach it the same way. I want to divide both sides by 5. You have to ask yourself, did I divide by a negative? No, there aren't any negatives in here at all. So I do not have to flip my sign around. 5 divided by 5 cancels out. It's a 1. So I get 1x is less than 35 divided by 5 is a 7. So I need to graph x is less than 7. Put 7 on your graph. Put in some more numbers if it helps you. I'm looking for numbers that are, this is on the narrow side, so smaller than 7. Remember, for your alligator, eat your bigger number because it's really hungry. Okay, so I'm looking for numbers that are smaller than 7. Numbers that are smaller than 7 are over here, correct? 6 is smaller than 7, 5 is smaller than 7. So I'm going to shade this side. Also, my variable is on the narrow side of the sign, and narrow goes to the left. Now, do I use a bracket or parentheses? This does not have an equal to on it, so I use parentheses. This is the answer to the graph portion of this problem. Now for interval notation, it's always left boundary, right boundary. This goes off forever in the negative direction, right? So this starts off at -infinity and it ends at 7. Infinities get parentheses. We had parentheses here, so this also gets parentheses. Okay. -7x is less than 49. If this is an equal sign, I'm dividing both sides by -7. I still need to do that. I still need to divide by -7. But since I am dividing or multiplying by a negative number, I have to remember to flip my sign around. Personally, as soon as I recognize I need to flip it, I circle it. because it's incredibly easy to forget to do. Even though you know you're supposed to do it, we have a tendency not to. So circling it helps me out. -7 divided by -7 is a 1, so I have x, and this needs to be greater than now. 49 divided by -7, a positive divided by a negative is negative, and that should be -7. Okay, so I need to put -7 on my graph. I need to figure out which side of this to shade. So -6 is here, -5, and you can go on up and you can put 0 up here if it helps. -8 on this side, -9 on this side. I'm looking for numbers that are bigger than -7. The numbers that are bigger are on the right. It's also on the wide side, and wide and that I and right go together. So shade to the right. This does not have an equal to on it, so this is parentheses. Now for interval notation. What is your left-hand boundary? A -7. What is your right-hand boundary? It goes up forever, so it's positive infinity. We said this gets parentheses, so does the infinity, and that's your solution. Okay. 6m is greater than or equal to -24. Pretend it's an equal sign. I would need to divide both sides by 6 to get it solved. Now, do I have to flip the sign? There is a negative involved, but it's in the top. We only have to worry when we are multiplying or dividing by a negative, not that the number we are dividing or multiplying is a negative. I'm dividing by a positive number, so I do not have to flip my sign. That cancels. I have m is greater than or equal to, that's going to be a -4. So let's put -4 on our graph. My variable is on the wide side, so I'm going to be shading to the right. Go ahead and put some numbers on there if it still helps you. You will eventually get to where you don't need them so much, but don't force yourself into that position until you are ready. Okay. This has an equal to on it, so this needs to be a bracket. Now for interval notation, our left-hand boundary is at -4. Our right-hand boundary, this goes up to infinity. Infinities get parentheses. This -4 got a bracket here, so it continues to get a bracket.